Hello and welcome to your geometry week of May 3rd, 2016. We are only about, this should say 17 days away from the very last day of school. So we are now in May, and May is the last month of the school year. So we are about, we've got about 3 weeks, a little bit under or a little bit over 3 weeks, 3 weeks and a day left in the school year. So that's exciting. Just remember that if you are behind the course, now is the time to make sure you're working on getting your missing work in. Remember, I'm only collecting redos from the current unit, and we are finishing, let's see this week what we're doing. We are doing the Unit 8 test this week, which means this is the last week for redos in Unit 8. So this is the last week that I will accept redos in Unit 8 because we are taking the Unit 8 test. So please remember that this is the last week for redos in Unit 8. That means that all redos from Unit 8 are going to be due on, let's see here, that would be the 9th. So you kind of get a little bit of an extra time here for redos, since this week the only thing we're doing in Unit 8 is the Unit 8 test, which is going to buy you some more time for getting some redos done. So please remember that all redos for Unit 8 are going to be due on Monday, May 9th. I will not accept redos after that day from Unit 8. Then this week we're moving on to Unit 9, Session 1, which is the last unit in the school year. And we're going to be learning about transformations, and this time around, I know we did transformations already back in the first semester. I think it was like one of the first units that we did. But now we're going to be focusing on them in terms of functions. So we're going to be looking at transformations in terms of functions. So that's going to take us back to the warm-up question that I wanted you guys to work on. So make sure you've got your math notebook out, and we're going to review what functions are and how we can solve for functions. So here we've got a function equation, f of x, which means it's a function. We're going to plug in a value for x, and that will give us our y value. That's what a function is. F of x equals x squared plus 2. So this is our function, and I want you to solve that function for f of 2 and f of 1/2. So remember that this is the notation for functions. It's just a fancy way of saying that here when I say f of 2, it means whenever you see an x in the equation above, you're going to plug in 2 and solve. Same for then when you need to find the f of 1/2. Wherever you see an x, you're going to plug in 1/2. So go ahead now and solve this, complete this warm-up problem. I would like you to do it in your math notebook, so go ahead and click pause if you need more time. Well, you're going to need some time. Click pause, and then when you're ready to check your work with mine, go ahead and click play. All right, so the equation that we're plugging x into, given different values, is x squared plus 2. So when we have f of 2, that tells me whenever I see an x, I'm going to plug in 2 and solve. So 2 squared is 4, 4 plus 2 is 6. So f of 2 would equal 6. What about when we have f of 1/2? Tells us to do the same thing. Whenever we see an x in our function equation, we're going to plug in 1/2. So we'll have 1/2 squared plus 2. I know 1/2 squared. I square each the numerator and my denominator, so I'll get 1/4 plus 2. Remember, in order to add fractions, you have to have a common denominator. So I'm going to change this 2, which is over 1, so that it has a denominator 4. So I had to multiply the denominator by 4, so I'm going to have to multiply the numerator by 4. So I get 2 times 4 is 8. 8/4 is the same thing as 2, but now I can add those two fractions together. And what do I get when I do that? And now we can add straight across the top and keep our denominator the same. So 1 plus 8 is 9. We get 9/4. So the function f of 1/2 gives us 9/4. 9/4. All right, I'm going to go on to the next slide now. So if you need more time, go ahead and click pause. So again, you are going to take the Unit 8 test this week. Finishing up our explorations on circles, and then hopefully you've already done that, because I did do the recording a little bit out of order this week, so most of you have probably already completed that. Just remember the reminder I said earlier about redos for Unit 8 are due on May 9th, so write that down. And let's focus on Unit 9, Session 1, transformations. So let's go ahead now and dive into transformations and learn about that so that you have a better understanding when you start doing the lessons this week. So transformations, the 3 transformations that you're going to study in Unit 9, Session 1 are translations. Again, we've already looked at translations early in the school year, but now we're going to look at it more with in relation to functions. So translations, remember, that's when you just take an object or a point and you move it. We're not changing the shape or size. We're just taking a point or an object, a figure, and just moving it. We're sliding it. We're moving it vertically, horizontally. So we're just moving it. And then we'll talk about reflections. And a reflection is when you take an object and reflect it over the X or Y axis, or the X equals Y, that diagonal line. And when you reflect an object or a point, the idea of reflecting is that the point will be the same distance away from the whatever axis you reflected over. So here we're reflecting, if you look here, we're reflecting a point over the X axis, and that point will be the same distance away from the X axis on either side of the X axis. And then last but not least, we will be looking at stretches and compressions. And this will probably be the stuff that is the newest for you, is stretches and compressions. So let's dive right in. Translations. I'm going to do a quick review of this because I think that you guys have seen this a couple times in your math classes before. So I'm going to plot a point right here. I'm going to call this point A. And point A has coordinates -3, 5. Point A has coordinates -3, 5. And we want to translate point A 4 units up and 2 units left. And then I want you to tell me the coordinates of the new point. All right, let's do it. So we are going to take this point and go 1, 2, 3, 4. I'm above my graph. And then 2 units. So we're going up 4 units, and then to the left 1, 2 units to the left. And that will get us to our new point. So up 1, 2, 3, 4, and to the left 1, 2. So our new point will be right there. And what are the coordinates of that point? So we're going up to 8 on our vertical axis. So the new coordinates would be -5 and so -5 and 8. Those would be the new coordinates. So we did that by actually plotting the points and moving them to get the coordinates of our new point, but we could actually just apply some math to the original coordinate. So our original coordinate was at -3, 5. So if we are going 4 units up and 2 units left, what we could do is just add and subtract from our original coordinates. So since we were going 2 units left, we are subtracting. So we would take -3 and subtract 2 units. And then to get our new y coordinate, we were originally at 5, but then we added 4 units because we were going up 4. So let me kind of color coordinate here. So 4 units up, we would add that 4 there. And if we're going 2 units left, we we would subtract from our x coordinate that 2 to show we were going to the left. And then we could just do the math. -3 minus 2, that's -5. 5 plus 4 is, what did I do there? 4 units up. 1, 2, 3, 4. Oh, that is 8. This would actually be 9. I did that wrong. I apologize. I should have picked a point that wasn't going to get us above the coordinates. So that's what I made a mistake. This line tick represents 7. This would represent 8, and this would represent 9. So our actual coordinate of our translated point would be -5, 9. So I apologize. That was a mistake on my end of picking a not so great point to do an example with, but that's all right. We fixed it. 4 plus 5 is 9. So we can either figure out new coordinates when we do translations by actually plotting the point and then doing the translation and finding what our new coordinate would be, or we can just apply the math to the existing coordinate. If we're moving left, we would take away from the x coordinate. If we were moving right, we would add to the original x coordinate. And vertical movement represents our y coordinate. If we move up, we're going to add to the original y coordinate. If we are moving down, then we would subtract from the original y coordinate. And then we can do the math to get our new translated point. All right, I'm going to go to the next slide, so if you need more time, go ahead and click pause. Moving on, reflections. Reflections. So we've got 2 reflections we could do. We're going to focus on in this unit with reflections over the x-axis and the y-axis. So let's focus with if we start with reflecting across the x-axis. Remember, the x-axis is your horizontal axis. I briefly explained this when we started the recording, that if we have a point, we'll call this point A, and we want to reflect it over the x-axis, it has to be the same distance away from the x-axis on the other side. So here, let's see how many, we are 1, 2, 3, 4 units away from the x-axis. So on the other side, we would need to be 1, 2, 3, 4 units away from the x-axis. And that would be our reflected point. Let's take a look at our coordinates here. So the coordinates of our first point was -2, 4. So we took the point -2, 4, and we reflected it across the x-axis, and our coordinate of our reflected point was -2, -4. So there is actually a pattern when we reflect points across the x-axis. The pattern that occurs is that the pattern that occurs when you reflect across the x-axis is that with your coordinates, the pattern is you start with your original x and y coordinate, and then when you reflect it, the x-axis is going to stay the same, but the y-axis will just change signs. It will be the opposite sign. So that pattern occurred when we actually plotted a point and reflected it across the x-axis. So if you look, our original coordinate was -2, 4, and then when we reflected it across the x-axis, the x-coordinate stayed the same. But look at our y-coordinates. They change signs. We've got 4 and -4. And that's the pattern that you'll get. Now, what about if we reflect over the y-axis? So let's go ahead. I'm going to erase what I've got here. So if you need more time, go ahead and click pause. Otherwise, it's gone. All right. Our y-axis is our vertical axis. The y-axis is our vertical axis. So if we choose a point, plot this, we'll call this point A, and it's got coordinates -3, 2, and we're going to reflect that over the y-axis. So it needs to be the same many units away from the y-axis. So we're 1, 2, 3 units away, 1, 2, 3 units away on the other side. What are the coordinates of our new point? They're 3, 2. So do you see a pattern that's kind of similar to what we did when we reflected over the x-axis? So if you look, we start with our original coordinate, and when we reflect it over the y-axis, now the x-coordinate is going to be opposite in sign, and our y coordinate will be the same. So that is the pattern that always occurs. If you don't want to memorize this pattern, just take a point and reflect it and see what happens to your coordinates. It's the easiest way to check yourself. I'm going to move on, so if you need more time with the reflections, go ahead and click pause now. All right, the stretches and the compressions. I wanted to spend a little bit more time with stretches and compressions because this should be new to you. So a stretch and compression, or a stretch and compression, is if you have a graph on the coordinate plane, and if we take that graph, we can stretch it horizontally, we can stretch it vertically, and we can compress it both horizontally and vertically as well. So I'm going to draw some graphs in and explain, give you guys more of a visual. So let's start here with a horizontal stretch. What does that mean? So let's go ahead and draw in a coordinate plane, and I'm going to go ahead and graph a quadratic. I'm going to make this my graph. So here's my graph, and I want to horizontally stretch it. So to horizontally stretch it, what I need to do is grab some points on my graph, and we're going to stretch it. We're going to pull it away from the y-axis. We're going to grab some points on this graph, and we're going to pull it away. We're going to stretch it away from the y-axis. We're going to pull it away from the y-axis. So when I do that, I'll show you what the graph would look like. So we're going to grab some points, and we're going to pull each point away from the y-axis. And that's going to stretch that graph out. It's going to stretch it out, and it would look more like this. So to apply those changes to each of those points on my graph, so if I have, there's points on the original graph, there's a whole bunch of points, and points are made up of coordinates. So to change those coordinates to apply that stretch, what we would do is we would multiply just the x coordinates by the factor, and then the y coordinates would stay the same. So if you have a stretch, a horizontal stretch, you would need to have a factor stretch factor that's greater than 1. So let's keep in talking about horizontal, and let's talk about a horizontal compression. So I'm going to go ahead and draw another coordinate plane in here and another original graph, and then we're going to horizontally compress it. So there's my coordinate plane. Let's go ahead and graph the original graph in blue. We'll do the same U-shaped graph. And now for a horizontal compression, we want to take each point and push it towards the y-axis. We're going to take each point and push it towards the y-axis. So we're going to take each point and push it towards the y-axis. And when we do that, we're going to get a new graph that is compressed inwards towards the y-axis. And when we do that, each of our points that were originally on our original graph are now going to be, again, multiplied by a factor where we just multiply and change our x of our coordinate points of each point that was on the original. The y coordinate will stay the same. We're just changing the x coordinate. And here you're going to have compressions, a horizontal compression when you're anything that is greater than 0 but less than 1. So if you have a horizontal compression, the factor would have to be less than 1 but greater than 0. So things like 1/2, 1/4, etc. What about vertical stretches and compressions? So let's do the same thing here. Let's take an original graph. So I'm going to go ahead and put in a coordinate plane again. Coordinate plane, I'll draw one in here while I'm at it. And we will graph the original graph in blue, just like we did before. We'll do the same thing. So I'm going to go ahead and draw my original graph. And now, for a vertical stretch, what we do for a vertical stretch is each point is going to be pulled away from the x-axis. So we're going to pull each point away from the x-axis. And I'm going to move my graph a little bit. I'm going to move it up like that. There we go. So we're going to pull each point away from the x-axis, away from the x-axis. So we're going to pull each point away from the x-axis. So here, these would get pulled down. We want to pull each point away from the x-axis. So when we have a vertical stretch, our graph then is going to look more like this. It's going to get kind of skinnier towards the y-axis. And here, when we're doing a vertical stretch, only the y-coordinates are going to change. Only the y-coordinates would change. The x-coordinates would stay the same. The y-coordinates would change. Last but not least, let's do our vertical compression. Let's draw an original graph in here. And for vertical compression, each point is pushed towards the x-axis. Each point is pushed towards the x-axis, and let's see what that looks like. So each point is going to go towards the x-axis, towards the x-axis. And when we do that, we're going to get a graph that looks more like this, where again, only our y-coordinates will change. Only our y-coordinates will change. This table is found in Unit 9, Session 1. I pulled this table from your lesson, so you do have that to refer back to. It's super helpful. It is in your lessons. I'm going to go to the next slide, so if you need more time to take notes, go ahead and click pause now. Otherwise, I am moving on. Alrighty, so let's look at an example here where you're going to apply a factor of a vertical stretch or compression, a horizontal stretch or compression to a point. And let's go ahead and do that. So an example. So here we've got a question that says, give the coordinates of a point. So give the coordinates of point C, which has the coordinates -5, 2, when it is vertically stretched by a factor of 3. Okay, let's pay close attention to what kind of stretch or compression. What do we have here? We've got a vertical stretch. A vertical stretch. So we're dealing with this part of our chart. We've got a vertical stretch. Our factor is 3. And here vertical stretches have to have factors that are greater than 1. And it says when we have a vertical stretch, only the y-coordinate changes. It says only the y-coordinate changes. And you're going to take that y-coordinate and you're going to multiply that y-coordinate by the factor. So if we have our original coordinate is -5, 2, our new coordinate, the x-coordinate is going to stay the same. The rule tells us only the y-coordinate changes, and we're going to take that y-coordinate, which was 2, and we're going to multiply that by our factor of 3 that we are vertically stretching by. So we're just going to do the math. 2 times 3 is 6. So our new coordinate would be -5, 6. We're only changing the y-coordinate when we have a vertical stretch. So now if you want to take a look at number 2 and see if you can figure that one out on your own, go ahead and do so. You can click pause and try to figure that on your own, and then we'll do it together. So number 2, the question says, given the coordinates, or give the coordinates of point C 1, 6, so point C has coordinates 1, 6, when it is horizontally compressed by a factor of 1/2. Horizontally compressed. So those are the words that we need to focus on, is that they're horizontally compressed. Horizontally compressed. So I'm going to come over here. Horizontal compression is this part of the chart. And now it tells us that only the x-coordinate changes. So we're going to take the x-coordinate and multiply it by 1/2. The y-coordinate is going to stay the same. So if our original point was 1,6, then to get the new point, again, our x-coordinate is going to stay the same, but our y-coordinate is going to be divided by 2. So our new point would be 1, 3, because 6 divided by 2 is 3. So our new point would be 1, 3. Only, oops, I did that wrong. Stop, stop, stop. Hold on, hold up, everybody. I was looking at that, I'm like, wait a minute. With a horizontal compression, only the x-coordinate changes. I did that opposite. I did a horizontal stretch, but we're doing a horizontal compression. So the x-coordinate is the one that changes. The y-coordinate stays the same. So we're going to take our x-coordinate and multiply it by 1/2, or take that and divide it by half. And then, so 1 times 1/2 is 1/2. And then our y-coordinate stays the same. So that would actually be the coordinates of our new point after it is horizontally compressed. So that's how you can use that table to really help you. And you'll have a couple questions like this on the assignment this week. Alrighty, so again, this chart will tell you which coordinate will change when you have a horizontal or vertical stretch or compression. You can see here, horizontal stretch, the x-coordinate will change and the y-coordinate stays the same. Here, when you have a vertical stretch, the y-coordinate changes and the x-coordinate stays the same. When you have a horizontal compression, the x-coordinate changes, y stays the same. When you have a vertical compression, the x-coordinate stays the same, and the y-coordinate chart changes. Alrighty, I'm going to go on to the very last slide, which is the key phrase assignment slide. So let me get that written up there for you. So we talked a lot about vertical stretches, compressions, horizontal stretches and compressions. And when you have a stretch or compression, vertically or horizontally, we talked about how one of the coordinates will change. So my question to you is, when you've got a vertical stretch, which coordinate changes? Is it the x or the y? And that's your question for the week. Let me know if you have any questions or need any help as you're working this week. Otherwise, have a wonderful week.